if you're looking to optimize your Kubernetes cluster and you don't know where to start, then this episode is for you. This episode will explain how to optimize your environments and especially your Kubernetes environments. Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on how to observe a given technology. Today's episode is part of the Kubernetes series, but in fact, it could be related to any technology that needs to be optimized. Today's episode will be focused on how to optimize your Kubernetes cluster. If you enjoy today's content, don't forget to like and subscribe to the channel. So let's see what we're going to learn out of this episode. We'll start with an introduction where we will see how complex it is currently to configure and optimize our environment. Then we will explain what is the process to manually optimize our system. Because it's a Kubernetes episode, we will obviously see the various settings that will help to optimize the behavior of our cluster. Then I'd like to introduce a very smart solution that will help us to optimize, and I'm referring to Akamas. Last, we will do an interview with Stefano Doni, the CTO of Akamas. He will walk through on how to configure Akamas, and then we will run some simulation and share some results with you. All right, so let's start with the introduction. Most of the technology stack of the market, like the web servers, so like Apache and JNX, or the application servers for Java, like Tomcat and many others, any Java environment like JVM, the databases, so SQL or NoSQL, so SQL like MySQL, PostgreSQL, Oracle and others, and for non-SQL like Mongo and others, they all have configuration files. And if you change the settings of those configurations files, it will adjust probably the number of authorized, number of connections, the thread, the worker, the size of the heap, and way more, in fact. So depending on those values, the system could behave completely differently. It could start to be very slow, consume more resources, and impact our end users. So the main issue is that configuring an environment is usually something that nobody is considering during the project. It happens quite often that we use the default configuration in our production environments.
Oh, okay.
The most complicated part is that the settings usually depends on the design, the architecture of the solution, the load, the usage of our system. So there are no standard and optimal configurations for everything. This is why this task used to be handled by lead technical architects and performance engineers. So the question is, how do you optimize a system? What is the manual process to optimize a system? Optimizing a system has been a manual task that has been usually considered to be quite expensive and time-consuming. Yeah, of course, because we could spend months and years optimizing our systems. That is a reason why you need to scope your optimization. What are we expecting out of the optimizations? What is the goal? The goal could be defined in response times decreased by, let's say, 100 milliseconds, or the memory usage is less important, the CPU usage is stable over time, we have less errors, we have an exceptions rate that is under 5%, or we can also think about the cost if we want. Of course, you never optimize your systems directly in production. When modifying the settings of our servers, we have clearly no idea on the consequence on our environment and on the experience that we provide to our users. So what is the approach? First, you need to have a load testing project that will reflect a representative production load. Here, the focus is on validating the given configuration, not stressing the systems, of course. We are not fishing for bottlenecks, we are fishing for optimization. Step 1 seems natural and easy, but remember, building a test reflecting production load is not an easy task because you need to understand precisely your environment, how your system is being used during a representative production hour. What are the main user flows done by our users? By user flow, I'm thinking of use cases. It's basic, but keep in mind that we need a load testing project with the main actions, the main use case that our users are doing in our production environment. We also, of course, to make a representative test, we need the number of concurrent users. Not active users, not concurrent users, but keep in mind we're going to do a lot of transactions. So the number of transactions per second of your key transactions. And of course, your user, if you just stressed by hitting heavily your servers, you will probably not reflect real life production activities. So you need also to gather the user think time. It will basically change the pace of the traffic. And if there are any network constraints related to your users, because probably they are utilizing the mobile connections, you should also consider to add that in your simulation. To have a realistic load test, you need a significant number of data sets to run in relevant results. If you don't have enough data sets, you will probably utilize your database differently. If you have the same assets, you can run into locks in your systems. So this is not a realistic production problem. So you should make sure that even your data sets make sense. Make sure that you have enabled enough observability to understand your environment. You are optimizing your system. So if you don't collect things and you don't understand things, you won't be able to take the right decisions in your optimization process. You need to analyze your load test and determine if the test that you have analyzed is the baseline of your current system. You need a baseline because you will compare things based on that baseline. Once you have the tests and the benchmarks, let's understand the parameters that we could modify in the settings of our software stack. Because clearly, depending on what's the goal of your optimizations, there will be clearly different type of sets of parameters. So you need to define which one you want to modify. Then once we have all the inputs, it's just time that we need and patience. Because we cannot change everything in our systems, otherwise we won't understand what is causing the improvement or in the other way, the regression. We need to change one single parameter. We do the change, we run our tests, and then we analyze to compare the results with our baseline. If we see any improvement, then the value that we have changed is positive. So we can move to another parameter. Remember, don't change all your settings in one time, because otherwise you won't understand which settings has improved your system. So at the end, it's an iterative process where you modify one single settings, you run a test, you analyze, you compare, and you make a decision. That is the reason why it could take forever, because if you don't set precise goals when you do manual optimization, you can basically spend hours, days, weeks just optimizing for very micro milliseconds. What can we optimize in your Kubernetes cluster? As explained in our first episode on Kubernetes series, Kubernetes relies on nodes, infrastructure. So depending on the sizing of your node, you can observe issues related to the way Kubernetes schedule our workload. Let's take the example of one Kubernetes event, OM kill. If you're not defining your request and limits, Kubernetes could kill your workload, but more important, our application could provide unstable experience to our user with a higher failure rates and a significant unstable response time. A lot of horror story has been shared over the years at KubeCon related to this topic. So here is the link. You will find a lot of different stories shared by huge company and very popular brands like Zalando or Airbnb, and most of those stories are related to request and limits. Kubernetes schedule our workload on nodes based on resources. So defining request and limits will basically help Kubernetes to schedule our workload. And also there's another thing is from the moment you define request and limits, Kubernetes will define a quality of service. But what is a quality of services? Well, like mentioned, if you define a request and limits in the specifications of our deployment files, then Kubernetes will automatically define a quality of service. If request equal limit, then Kubernetes will define this as guaranteed. If request is under your limits, then it's going to be defined as burstable. And last, if there is no limit, there is no request, it will be considered like best effort. Requests have another advantage. It will help us to manage the node usage and help Kubernetes to schedule our workload based on our resources. So optimizing our cluster could mean defining the right size of our node and the right requests and also limits. It seems that it's two trivial parameters to set on our containers of our pods. So the requests for the CPU and requests for the memory. Request is clearly easier to understand. So let's start with it. Memory is expressed in bytes, so nothing complex. We need to measure how much memory we need to run our container. So that could be easily measured with observability. CPU is not expressed in percentage, it's expressed in millicores. So 1000 millicores is at the end one core on one of our nodes. The problem is that if you're not defining properly the value of the requests, then you can run into critical and unacceptable situation. If request is too low in terms of CPU, then our application will be throttled, and that will cause some significant increase in the response times and in the number of errors. If memory is too low, we are not able to run our workload, so potentially our application won't be able to start. On the other hand, if we define requests that are too high, As a consequence, Kubernetes will allocate resources, but those will never be used. So we won't utilize efficiently the resources of our cluster. So if you run in a Kubernetes managed environment in the cloud, you will pay more for the resources that you never use. And now see the limits. On the other hand, if the limits are not defined, at least in terms of memory, Kubernetes will kill our workload, our pods, and throw an OM kill event. OM kill event stands for out of memory. So we have reached the memory that we have defined in our limits, and Kubernetes decides to kill it. If CPU limit is too low, you will be throttled. So limits is usually way more complicated to define. Memory is expressed in bytes. So at the end, we only need to follow the usage of our containers. On the other hand, CPU is not expressed in many cores, but expressed in function time. If I define 1, it won't mean 1 core, but it will mean 100 milliseconds of CPU time. This is more difficult to understand, but in fact, it's pretty much aligned in how Linux allocate our resources with container environment. Linux utilizes C groups to allocate resources, and C group use completely fairly scheduler, CFS, to handle resource limits. Let's say that the limits would be like a contract with the hardware in our cluster. We will define the maximum resource authorized for our containers. CFS manages CPU allocation using quota and periods. A quota is defining the maximum CPU time that a task can use during a period. In other words, our pods can only use specific CPU time during a given period. If the pods require more, it will be throttled until the next period. Each core of our nodes can do 100 milliseconds of work in a 100 milliseconds period. So let's take an example. To illustrate this technical concept, we run a pod on a 2 CPU core machines. The pods run a program that requires 200 milliseconds to complete its task. If we assign a limit of 2 on our workload, it will be translated into a quota of 200 milliseconds. So if it's 2 cores, each core gets 100 milliseconds of work in 100 milliseconds of periods. In that particular case, we don't have any throttling. We are exactly at the same period. If we now increase the number of cores, so we have more threads, then each core could theoretically allow us to execute that task in 50 milliseconds. So let's remember, we divided by 4, so we have 50 milliseconds to execute the task that we were looking for. In this case, our program will run 50 milliseconds on 4 cores. So it means that if we need to do more, another task just afterward, then it means that we have consumed our limits. So we will be throttled for the next 50 milliseconds. The other angle in optimizing our cluster is the cost. If we are using a managed cluster, then we probably want to size our nodes and the number of default nodes to reduce the cost of our environments. So optimizing is expensive. Because we need time to run all those simulations and make the right decisions. So how can we make it more efficient? Well, I have a solution for you today, and the solution is named Akamas. So let's have a look at Akamas. Akamas is a solution that optimizes a system utilizing machine learning to automatically find the best configuration parameters of the software stack. Akamas automates the performance tuning process. It works in 5 distinct phases. First, it applies a configuration to the target systems. So basically changing the values, the settings of your environment. So that's the first step. Step 2, it runs experiments, which is in fact a load test, to measure the benefit of the change applied in our environment. Step 3, it gathers performance metrics from the observability stack that we have in place. So in the case of Akamas, it supports Prometheus or Telemetry. Step 4, it automatically analyzes the performance test to compute a score based on the goal that you have defined. So for example, we want to maximize the throughput, minimize the costs, decrease the response times of, let's say, 200 milliseconds, and so on and so forth. Step 5, AI and machine learning define a new configuration of our environment, and then the recycle repeats. So we could run during 24 hours, and then at the end you will have lots of meaningful benefits. So how can we use Akamas? Well, you simply need to install it in your environment. Akamas has several terminology within their product. So a system is the application, the service, the microservice, or that we are looking to optimize. So a component is a sub-element of our system. Component type is a blueprint for a component that describes the type. In Akamas, component types has a set of parameters and metrics. Let's say we want to optimize the hipster shop. So the cart service is a component. It's a Java microservices. Then the component type would be a JVM. We could attach to it all the parameter settings available within a JVM. So garbage collector settings, number of threads, and so on. A JVM has clearly relevant metrics exposed. So the garbage collector duration, the number of threads, the heap size, the memory usage, and way more. Parameter is a property that Akamas can modify to optimize the system. Metric, well, I guess you know what it is. It's a way to measure some behavior of our system, and moreover, of our component. Telemetry, from the Open Telemetry episode, we know that telemetry means remote measurement. In Akamas, it's a software component that allows Akamas to retrieve data from our environment. There are several telemetry providers in Akamas: Dynatrace, Neoload, Prometheus, LoadRunner, and others. A workflow. It's a set of tasks that needs to be executed to evaluate a configuration. For example, let's say for a given experiment or a given optimization process, I probably need to first connect with SSH to an environment, edit a specific configuration file, then I probably need to restart a system, and then I will probably launch my load tests. Study is an optimization initiative on a given system. A study will need to have a system, parameters to optimize, metrics that needs to be collected, and a workflow to run the study. We need also a goal. The goal is crucial and important because that will be the objective for the machine learning that will determine how we want to optimize and where we're going to stop the optimization. Experiment. Experiment is evaluation of a configuration. It's technically the results of a configuration change. So we change some settings, we do some tests, at the end we have a result, so that's an experiment. Trial. If you do experiments, you probably want to do several trials. It's a repetition on the same experiments, just to confirm that the results that we just saw and measured is not noise, and it's something that we are always seeing in our environment. So to conclude, we want to tune a system, let's say Kubernetes, based on several components. So they are the pod, the container, and the nodes. So we will need to define a study on Kubernetes with a couple of parameters. There is the CPU and memory limits that we have to define. We can also tune up the number of replica, for example. And if we want, we can also tune the infrastructure nodes, the type of cloud instance. So with the type of cloud instance that will basically have a certain number of cores, a certain number of memory, and so on. How many number of nodes do I need? The workflow, so first, let's say we have a Terraform script that will basically deploy everything in our environment. So we will first modify the Terraform script with a new setting. Then we will probably commit the script to our version control. We will run a script that will provision a cluster, that will deploy Prometheus. Once it's been deployed, we want probably to deploy our application. And once everything is ready, we can run our load test. The goal, we want to minimize the overall costs of the application with the cluster. We will have to define an SLO that the machine learning will consider in the optimization process. So let's say the error rate needs to be under 4% and the response times under 2 seconds. In order to take advantage of Akamas, we just saw through our short presentation that there are a lot of concepts. Therefore, I would like to call a friend, Stefano Doni, CTO of Akamas, and I would like to take advantage of his expertise. Stefano could help us explaining how to configure Akamas to tune our Kubernetes cluster and run our study to optimize this cluster. Hi Stefano, how are you?
Hi, I'm Rick. I'm great, and thanks for having me today.
Great. I'm currently doing an episode on how to optimize a Kubernetes cluster. And I have already explained the process to manually optimizing a system. I also briefly explained a few settings that needs to be considered when optimizing a Kubernetes cluster. The reason why I'm calling you is to clearly take advantage of your expertise on how to optimize a system in a clever way. Before moving to the actual solution, could you briefly introduce you to the community?
Yeah, sure. Hi everybody, I'm Stefano Doni, CTO and co-founder of Akamas. I have pretty much 16 years of experience in the performance engineering space. I always love and have a great passion about making things run faster, being more efficient, and that's why we actually founded Akamas.
Usually, when we build a software, we try to provide a solution to the market that will resolve our main pain. But behind each solution, there is always a story, a reason. Could you reveal the story behind Akamas?
Yeah, sure. Basically, we have been doing, also myself, have been doing lots of performance optimization works for many of our customers in the previous 20 years or so. So lots of international customers. And then what we found out is that actually the process of performance engineering, the whole process that the industry is following today, is basically not giving the result that you want to achieve in a kind of efficient way. So we were actually struggling with making the application run faster, being more efficient, being more reliable, due to the complexity. So systems today are becoming more and more complex. Think about all the knobs that you have, all the technology layers that have many more options that are increasing in the terms of complexity, but also the microservices movement, the cloud native movement. All of that is kind of making our work too complex, so we are not actually able as humans to actually do the best optimization possible. And on the other side, the other big trends is the whole DevOps. So making releases faster and faster, that's a key business initiative. So on one side, we have this kind of perfect storm. On one side, we have the complexity that is increasing, so we cannot keep actually optimizing system with the current processes. And on the other side, we have less and less time to do so. So we really found out that the current way the industry, performance engineering industry is tackling the optimization and tuning problem is not working anymore. So that's why we decided the world needed actually a better approach, a kind of next generation approach where we can really make sure applications are faster, are most cost efficient, are more reliable in a kind of autonomous way. So without the help of the humans, but actually supporting the performance engineers and DevOps team to do this kind of work in a more automated fashion.
Interesting. So it means that Akamas is not only designed to optimize Kubernetes, we can clearly use it to optimize any system. Are there modules that allow us to do specific optimization?
Yeah, on one side, the platform that we have built is flexible and generic, and it can actually optimize any technology. On the other side, we have built specific product capabilities to help the user, the performance engineers, or the developers of DevOps to actually make this task easier. So within the platform, we have this concept of optimization packs, which are product extension that actually, in a way, bring in the knowledge of the specific technology. Most important things that an optimization pack includes, for example, are the key parameters out of, for example, 800 parameters that you have on the JVMs. What are the most important ones? But also relationship among parameters. So sometimes a parameter needs to be lower than another parameter. So all those kind of complexity is really the complexity of the different technologies. So our approach is actually a combined approach where we use AI to smartly explore this kind of huge configuration space in a smart way. But then we have optimization packs, which actually brings in the domain knowledge to actually realize this kind of vision of automated performance optimization in a kind of more approachable and easier way to optimize systems.
Let's jump directly to the main topic of today. Even if we have presented few concepts related to Akamas, I'm pretty sure it's still unclear for all of us. What would be the journey to create a study, to optimize the price of our cluster, and of course, guarantee that we are still delivering a performant and stable application? How would you define this experiment in Akamas?
Yeah, sure. So what we are going to show you today is how we can optimize a Kubernetes application. We are going to use Google Online Boutique as an example application. It's a microservice application that is made up of about 10 microservices running on Kubernetes. So the goal for our optimization will be to actually optimize the cost efficiency of this application, meaning that on one side, we want to make the throughput of the application higher. So we want to have higher performance application, and at the same time, we want to decrease the cost of those applications. So of the different microservices. So we are going to see this use case and how we can actually configure Akamas and the kind of results that we can achieve in this scenario. So first of all, Akamas, before actually jumping into the actual process, I want to clarify that Akamas was built with kind of modern approach and nicely fits into modern DevOps processes and GitOps processes. So actually we have two ways of interacting with Akamas. One is through a CLI, where actually you can describe and manage all your optimization resources as YAML files, and those YAML files can easily get in a way version in your Git repositories alongside your application and infrastructure code. And that is very handy, by the way, also to automate the optimization within CI/CD pipeline, for example. And then we are going to see the results of the optimization in our UI, which is typically very interesting used to analyze the outcomes of the optimization. So what is the best configuration? What are the trade-offs among the different metrics that Akamas found out when we are optimizing the system? So the first step, we have basically a four-step process to actually prepare an optimization within Akamas. So the first process is to create what we call a system. As you have already introduced, basically a system is a description of the application that we are gonna optimize. So first of all, we need to create a system, and here is an example of the YAML files that describe the system. As you can see, this is the system related to the Online Boutique. It's very, very simple. It's just a name and description because the system for us is just the application. most importantly, what we are going to optimize with this in this use case is actually the container settings. So more in particular, we are going to optimize the CPU and memory limits for each single container, for each single microservice within this application. So once we design the system, which is kind of in a way group of our microservices, we are going to define actually the actual microservices themselves, so the components that we are going to optimize. So the online boutique application is made up by close to 10 microservices. This is an example of just one microservice, the cart service, and this is where we can model the cart service within Akamas. So in this way, we are stating to Akamas that actually this component will be something that we are desired to tune. So as you can see, what we have in this YAML file, we have basically a name, a description, and what is very importantly is that this is a Kubernetes container which has the various parameters that we have described before. And the key thing to realize is that we do not need actually to describe here all the parameters and the metrics of a container. We can simply say this component is actually of type Kubernetes container. This is all we need to say as user, because due to the optimization packs, Akamas will know what will be the parameters and the metrics related to a Kubernetes container. So we don't need to do that when we describe our system, as we are going to see in the UI. So that's just one simple microservice. Depending on the scope of the optimization, we can of course select what we want to tune. We will be creating other services, other components within Akamas, and then we can see the result of our modeling into the Akamas UI. So this is the UI of the product. I can go to the system and I will find out the online boutique system that we have created before with our CLI. And if I click on the online boutique system, I can see all of the components that we have created. So you can recognize, for example, the cart service, which is the container that we have defined before. And you can instantly see the power of optimization pack here, because I can directly see for this Kubernetes container what are the key parameters that I have for this specific technology. So again, I have CPU limits, memory limits, request, and memory request. I have all the metrics related to a typical container, so CPU usage, throttle time, memory, etc. So all of that comes out of the box due to the fact that Akamas knows what is a Kubernetes container, so they didn't have to do this kind of effort. And that was the first step. So the first step, I've described my application, my system, that of course I need to do just once at the beginning. I can do, of course, once I have defined my system, I can do several optimizations just reusing what I have defined. So the second step is actually to create what we call the telemetry. So Akamas integrate with lots of telemetry tools, monitoring tools. For us, the telemetry is the way in which we bring in metrics related to the system that we are optimizing. Akamas supports a variety of tools. So the approach is that it's agentless. So we do not have our own agent, but we integrate with existing monitoring tools. So in this case, in this environment, we have a Prometheus server, which is monitoring our Kubernetes environment and also our application metrics. So we just need to actually configure Akamas to point to our Prometheus server, which we have previously configured, and that's it. So that's the corresponding YAML that we simply need to create. So as you can see, we state that the provider is Prometheus. By the way, we have other providers also for enterprise tools like Dynatrace. I configure the address and the port, and that's it. By the way, you can also see that I configure additional custom metrics. So additional metrics with respect to the Kubernetes ones that will be monitored out of the box by the Prometheus provider. But I have also configured other metrics that may be handy for our optimization purposes. So for example, as I'm gonna use online boutiques comes with a load testing tool built-in, which is leveraging Locus. So in this case, I'm also bringing into Akamas the Locus metrics, like for example, the users, the transaction throughput, the error rate, etc. So those metrics are typically handy both for an analysis purpose. So within the Akamas UI, I will be able to analyze those metrics as well as the other container metrics. But I will also use, for example, the throughput as a goal, because I want to say, okay, I want a higher throughput for my application. So once I bring in data with whatever query that I need, I can actually leverage those metrics when I will define my optimization goal. So that's it for the second step. So the third step is that we need to configure our workflow. So the workflow in Akamas is a very important concept, which means the way in which we automate a performance experiment. So the workflow basically is where Akamas lets you automate two main tasks. The first one is how can we apply the parameters that AI has anyway suggested. Akamas AI will suggest a parameter, but the parameter will need to be applied to the system. And the second task that we have in a workflow is to apply the workload. So again, as we are going to see, we integrate with load testing tools so that you can automate and leverage your existing load test for optimization purposes. So you can see here the YAML file for this workflow that I have already prepared. So basically, the workflow is made up of several tasks. So for example, you will configure the online boutique application. So this is where we are going to apply the parameters in our boutique YAML, which is the file that we are going to use with kubectl to actually launch our Kubernetes application. This step, we simply configure this file, which I have here. So this is a standard boutique YAML file that you can get out of the Google repository. The only thing that is different, you can see the various containers here, the deployment, for example, related to the email service, which is one of the services. The only thing that you need to do is you need to specify those kind of templates within your configuration files. This works, by the way, for Kubernetes. This might work for databases, so Java, application server, whatever you have. And then Akamas will actually go here and apply. Then we put here all the actual values of the parameters according to what AI suggests. So that's the way that every single container gets configured. And then, of course, we go back to our workflow. Once we have configured our YAML file, we need to apply the new configuration. Basically, we will simply do a kubectl apply in this case. We check the application is up, and then basically we start the load test. So again, in this case, we are going to use Locus as a way to stress the system. We wait a little bit for the load test to do its work, and then we stop the load test. So that's the workflow. And again, you can see basically the workflow in our UI here. So what we have created in the YAML files, it's visible also in our UI, so that you can double check that everything is correct. And then the last step is really the most important one is to configure the study. So the study, as you had already described, is basically where everything comes together. It's where you describe to Akamas what is the optimization goal, which application am I optimizing, which workflow am I using. By the way, I can create many workflows for different applications. What parameters am I tuning? So in this case, again, the study gets defined in a YAML file where you can see, for example, I have the name of my study. I can state what is the system and workflow that I'm going to use, of course. Most important piece is the goal. So in this case, what is the goal of this optimization? What I would like AI to help me achieve? So in this case, you can see that the goal has an objective so that I can state I want to maximize or I want to minimize a metric, for example. And the formula states what you really want to achieve. So in this case, you want to maximize the transaction throughput. Again, this comes from the telemetry from Prometheus, divided by the cost. So the cost is a matrix that measures the actual cloud cost of our containers based on some pricing figures that we got, for example, related to AWS Fargate, which is a serverless Kubernetes engine, which lets you price the Kubernetes service based on the size of the containers. So Akamas will define the size of the various CPU memory limits of the containers, and as a result we will pay a given cost on the cloud. And the beauty of that is that we can include a cost as a direct metric for the AI to actually optimize. You can also see the way, as you were telling correctly, for performance engineers it's very important to actually being able to define constraints. So in this case, we can state to the optimization, of course, that we don't want the application be slower as a result of an optimal configuration. Perhaps AI may find a configuration that is very, very cheap, but that might, in a way, make the application run too slow. So we can state those kind of constraints. So for example, I have absolute constraints, which means that I can express values, add values for a matrix. So I can say the response time might be less than 500 milliseconds and the error rate less than 2%. I can also express relative constraint to the baseline. So I can say error rate should not be higher than 1% with respect to what I had in the baseline. So that's the most important part. So we can define the goal, and then we can define the parameters. So what are we gonna tune in this study? And so you can see in this study, basically we have, for the different microservices, we are gonna tune the CPU and the memory limits. I've decided here to tune all of the microservices. So those are 22 parameters in total that Akamas will consider. And then last piece that I'm gonna define in this study is what is the baseline configuration. Baseline configuration is the reference point for this optimization is what we have today. So what are we going to compare against? This might be the vendor default or what you have today as regard your setting in production, etc. So with the baseline step, we can say for each parameter what is the current value that Akamas will consider as a starting point. And once we have defined that, we simply state, okay, now let's do an optimized step. I can choose, for example, let's do 50 experiments, and this is where AI kicks in. And actually for each experiment, we'll execute all of our workflows. So we will apply the configuration, we will trigger the load test, we will gather the matrix, we will evaluate the goal. So that's one experiment. So I can state, for example, how many of them I want to achieve, and at the end, the study will give me the best configuration.
All right, that was super clear. Now we know how to configure a study in Akamas. Could you explain us how you can trigger a study, and maybe explain how you can automate the execution of the study through a pipeline or any automation process?
With our CLI, we are ready to start the optimization process. So you can see here the start command that I'm launching with the Akamas CLI. So Akamas start study, and that's the name of the study that I gave. I can actually go through the UI. By the way, I can also start the study here. So that's the UI that is showing us our study. By the way, this kind of study takes a couple of hours to execute. So here I have the study that has been already executed and is completed. So the optimization was run for about 6 hours, as you can see here. And by the way, let's now have a look at the results. So that's once I go to the study, I can see my summary tab, and here Akamas presents me the most important information about the study. So you can see here that I have our goal. We have here under details, we can see our constraints that we have configured. So the number of transactions per second and the error rate less than 2% and the response time less than 500 milliseconds. And then we can see also the number of parameters that we were tuning, 22 parameters. And then we configured 51 experiments, so 51 different execution of our complete optimization process that we wanted to run this optimization for. So that's the complete optimization. So it's interesting to see the results that Akamas achieved in terms of the best score. We were able to achieve pretty substantial increase in terms of cost efficiency. So 55% increase in transaction per second per dollar, which is our unit for the goal. So you can see that the baseline was reaching 0.37 transaction per second per dollar for this particular application, and the best configuration was able to get 0.57 transaction per second per dollar. But let's have a look at how it works. So under progress, we can actually see how the different experiments are being generated during the optimization.
So you can see here, starting from experiment number 1 is what we call the baseline configuration. So remember, during the configuration of the study, we can say to Akamas, okay, first of all, let's run an experiment where I can specify the baseline configuration, which is the existing configuration before actually starting the tuning. So you can see actually here the parameters and the value of all the parameters in the baseline configuration for each experiment. So experiment 1 configuration, you can see here all the parameters that we asked Akamas to optimize. So those are the components, the different microservices, the CPU and limits, the CPU and memory limits for each component, and then you can see the value. So the value of the baseline configuration is basically what I have today. So the number of CPUs and memory that I have assigned to the different microservices. That's the baseline configuration, and you can see the score is 0% because actually it's our reference point. So from the baseline, starting from experiment 2 and 3 and 4, etc., it's where the AI really comes into play. So starting from experiment 2, we can see all the different parameters that are being changed by our AI engine. So again, we can click on the configuration button. We can actually explore which kind of settings AI suggested for this experiment. So again, the same component, the same parameters, you can now see that Akamas AI is suggesting different parameters. So for example, in the baseline, we have 0.3 CPUs for the ADI service as regards the CPU limits. Now the AI is suggesting 0.15. Same is happening, for example, I don't know, on the memory of card service, we went from 128 and now Akamas is suggesting 176. So as you can see, each and every parameter gets a different value. So for each experiment, Akamas AI is changing all of the parameters. And that's really key in order to make the optimization process faster with respect to the usual human-based process, manual-based process, where we can change one thing at a time. So that's how the optimization actually progress. By the way, we can also expand each single experiment and see all the various tasks that are being executed to carry out the optimization. So remember, those are the tasks that we configure in our workflow. So for example, this is the configure online boutique task. Second task is the apply the new configuration. The third task is we check the online is up, we launch the load test, etc. So for each task, by the way, we can also see the logs and make sure that everything is running correctly. So for each experiment, basically Akamas AI goes autonomously, and you can see the score of each experiment here. The score basically is the value of the goal. So in this case, the scores are gray, meaning that they are worse than the baseline. So Akamas AI at the beginning is learning how to tune all the different parameters in order to maximize our score. So you can see that initially the experiment have a negative score, but pretty quickly actually AI starts to learn where are the best configuration and how the optimization or the different parameters should be tuned to actually increase our goal function, which in this case is cost efficiency. In order to best see how the optimization progress works over time, we can move to the analysis tab, where again we can see the exact same experiments, and now we can see a chart that shows us the score of the different experiments. So again, experiment 1 is 0%, is our baseline. The initial experiments have negative scores, as we have seen before, but you can see that starting from experiment 12, we can start getting higher and higher values. So you can really see how AI is learning by tuning the different parameters between the different experiments and learning from the past. For example, experiment 28, we already have pretty significant configuration improvement here, score improvement. You can see that we are almost to 26% improvement in cost efficiency after about a couple of hours. By the way, we can also see the absolute time here. Again, you can see how quickly Akamas AI is able to learn. Remember, for each single experiment here, we are changing 22 parameters. Think about doing that manually. What is also interesting to see is that we can, once Akamas actually complete its optimization, it's important also to understand how the different configuration compare in terms of different metrics. So for example, in this table, again, we have experiment and we have the score of each experiment. So basically the dots that we have seen before, but we can also have lots of other metrics that we bring in from the monitoring tools. So in this case, for example, I can select to see most important KPIs of my application. are, for example, the response time, the cost, the error rate, the response time, and the throughput. And I can quickly slice and dice in this table and see, for example, let's see the best configuration. So it was an increase in 55%. Let's see how that impacts the other application performance KPIs, or even my CPU utilization, my infrastructure, etc. So here I have selected the cost. So I can immediately see, for example, that the best configuration is actually decreasing the cost by 36%, which is good. And I can see, for example, that in this case, response time of this configuration actually increased by 50%. You can see here we are directly comparing the response time of the baseline with the response time of the best configuration. That is still within our SLOs. Remember that we set the SLOs as being 500 milliseconds. So for Akamas, this is still a good configuration. Of course, if you don't want that, we can set lower constraint. I can also see what happens over time with this configuration. So those metrics were the aggregated metrics over a load test that may last, for example, 1 hour or so. But as a performance engineer, we may be interested in seeing the actual response time metrics over time, what is happening. So if we compare metrics, or we go to the metrics tab, we can quickly compare different metrics. Throughput, for example. So throughput is pretty much equal. So I'm comparing here the baseline with the experiment 27 that I have selected. So I'm pretty much satisfied because I'm not, in a way, degrading my throughput, even though the configuration is less costly. And I can also see, for example, my response time. Let me select the response time matrix. Okay, and I can quickly see how good is the new configuration that Akamas found. So that the yellow one was the baseline, and you can see how faster now the application is thanks to the new configuration. If we go back to the summary, of course, we immediately show also the baseline configuration, the best configuration. So without having to dig deeper, Akamas just provide us the best configuration that actually achieved the highest score. So we can directly see for each single parameter the best value that Akamas achieved.
That's wonderful. In few hours, you were able to configure 11 services of the Hipster shop, tune the value of the CPU and memory requests and limits. It's impressive. So big question, how can the community try Akamas on their environment?
So the good news is that you can go on akamas.io and you will find a button to request a free trial. So it's you have 2 weeks actually in which you can basically use the product and do whatever you want. We also have prepared a couple of quick guides that you can find on explore.akamas.io.
So the study done on the Hipster shop, I guess you also have like a tutorial or a guide available on your website?
Yeah, exactly. So you will have also a guide for the Kubernetes performance optimization. So exactly this study you will find in a specific guide. So you can actually reproduce what we are showing today.
Stefano, you have answered all the questions related to our episode. Thank you so much for your explanations and sharing the results of this experiment. If we have any other question related to optimization, I will clearly call you back. Thanks. See you soon. Bye.
Thanks a lot. Bye-bye, everybody.
That's it for today's episodes related to how to optimize your Kubernetes cluster. We saw a few concepts, and we had this introduction on this solution called Akamas, where we configured the study. So the study is the experiments, and we also went through the various results that has been collected and explained by the CTO of Akamas, Stefano Doni. So if you enjoyed today's content, don't forget to like and subscribe to the channel. We will produce more episodes and more tutorials to help you in your project. See you soon for another episode. Bye.